Okay, so the other thing you guys can do with complete set is what I said we wanted to actually use it to solve an equation. We're going to make a perfect square trinomial and then be able to solve it using square roots. So I said the first thing you want to do is make sure your lead coefficient is 1. So for number 1, the lead coefficient in front of x squared is 1, so we're okay there. We don't have to divide anything. So the next thing we have to do is subtract our c term over. So I'm just going to make this x squared minus 12x plus what equals -4. We're trying to figure out what term needs to go in this spot to make this left side a perfect square trinomial. So I said the theme is take that b term, divide by 2, and square. So what is 12 divided by 2? 6. 6 squared is 36. So that's what we want to add. Now here's the part that you're going to forget, that I sometimes forget. This is an equation, guys. You have to keep it balanced and you have to keep it equal. So just adding 36 to the left side, you can do that, but you have to also remember to do it to the right side. So like I said, I will probably forget to do it. You guys will probably forget to do it. So just try not to forget to add it to both sides. You have to keep your equation equal and balanced. Just like if you subtract a number on one side, you do it to both sides. You don't ever just do something to one side of your equation. So now that we've found the term that makes this a perfect square trinomial, we can write the left side as a squared binomial. So this will become x and 6. And remember, you're always matching that term or that operation, whatever that first one is. So since it's minus, it's going to be minus 6 squared, and 36 plus 4 is 32. So now that you guys have a square binomial, now you can just solve it using square roots. So we'll take the square root of both sides. The square root and the squared exponent cancel each other out. And you're left with x minus 6 equals, and we have to simplify 32. So let's see, 4 and 8, 2, 2, 2, 4, 2, and 2. So pair, 1 that's left. So 2 times 2 on the outside, so plus or minus 4, square root 2. And then the last thing to do is just add 6 over here. And remember, if it's helpful to you guys, you can write this as plus or minus 4 square root 2 plus 6. If that's helpful to you guys, then trying to figure out where those pluses and minuses go, you can just add it on to the end. That's fine. But don't add them together because one has a square root or a radical and one does not. But that would be your final answer. So positive 4 square root 2 plus 6 and negative 4 square root 2 plus 6. So let's try number 3. So for number 3, the first step is making sure, is my lead coefficient 1? If it's not, divide by whatever is going to make your lead coefficient 1. So in this case, we have to divide this entire equation, guys, by 2. So that will make this x squared plus 4x plus 7 equals 0 divided by anything is still 0. So we like it when we divide by that lead coefficient and it's still all whole numbers. That means we don't have to leave anything as a decimal or a fraction. But now that that lead coefficient is 1, now we just go through that process of, okay, adding your c term over, finding the new c term that makes the left side a squared trinomial. So let's subtract that 7 over and make this x squared plus 4x plus what equals negative 7. Just subtract that negative 7 over. So I said take the b term, divide by 2, and square. So 4 divided by 2 is 2. 2 squared is 4. Don't forget to add it to both sides. And remember, the way you guys found that was taking 4, dividing it by 2, and squaring it. So now that we have our term, we can write this as a squared binomial on the left. So this will just become x plus 2 squared equals negative 7 plus 4 is negative 3. So now we just solve using our square root. So I'm going to take the square root of both sides. That will cancel out my squared exponent. And then we're left with x plus 2 equals positive or negative. As soon as I see that negative inside of there, guys, I want to be thinking, okay, I can't take the square root of a negative value. So this is going to have to be an imaginary value. So that I comes out and now it becomes just 3. So positive or negative I square root 3. If you want to make it 1i, you can. It doesn't matter. But then that last step is to subtract your 2. And remember, if you guys want to write it at the end, that's fine. So positive or negative I square root 3 minus 2. So that's it. So, is your lead coefficient 1? Check that first. If not, divide by whatever you need to make it 1. And then subtract your C term over to the right-hand side. Find the term that's going to make it a squared binomial. Add it on both sides, and then write that left-hand side as a squared binomial so you guys can actually solve it. So go ahead and try number 2 and 4. Number 5, it says the area of a rectangle shown is 72 square units. What is the value of x? So if we just set this up, guys, to solve it, and we're going to try solving it using completing the square because that's what we're focused on today. Remember that length times width is your area, so we have the length, which is 3x, times the width, which is x plus 2, equals 72 square units. So in this case, the only difference, guys, is that this equation equals 72 instead of equaling 0, like they did in the 2 examples above. But if I multiply this out, so I get 3x squared plus 6x plus, there's no other term there. So it actually works out nice that you guys can just leave that term there and it's still going to equal 72. In this case, there's no C term to subtract over. But what we do have to realize is that our lead coefficient is not 1. So we need to divide the entire equation by 3 first and make this x squared plus 2x plus what? 72 divided by 3 is 24. So now, take that middle term of 2, say 2 divided by 2 squared equals 1. 1 squared is 1. So that's what we want to add to both sides. And then rewrite the left as a squared binomial. And now we can take the square root of both sides. So square root, we get x plus 1 equals plus or minus the square root of 25. You could break it down, but it's just simply 5. And then subtract that negative 1 over. So x equals positive or negative 5 minus 1. Or negative 1 plus or minus 5. However you guys want to look at it. So, if we're looking at our problem, positive 5 minus 1 would give us 4 square units. So you could just write 4 units squared. Or negative 5 minus 1 would give us negative 6 units squared. So we said, if we're talking about a real world problem, we can't really have negative measurements. So it's really going to be positive 4. And you guys can always plug that back in. 3 times 4 is 12. 4 plus 2 is 6. Is 6 times 12 72? Yes. So x really equals 4 units squared. We don't want that plus or minus.